Welcome back. This should be an exciting video. Today we're going to take a look at writing to files using Java. The program in front of us declares a mathematical sequence, or the first 50 numbers of a mathematical sequence, in which each number is the sum of the two previous numbers. When we run this program, we see these 50 numbers printed out to our system.out stream, and we can view them in our console. But when we close this console for good, these numbers are lost. Our goal for today is to get these numbers printing out to a file rather than the system.out stream. In a file, they could be preserved. To help us with this task, we're going to make use of the java.io library, I/O standing for input and output. And we're going to utilize a class that lives in this library, the file writer. Let's declare a new file writer. And for reasons that will become apparent a little later on, let's have this file writer be explicitly set to null. Once we've done that, we can go ahead and instantiate it. In order to write to a file, we're going to need to know two important things. First, of course, we're going to need to know what to write to the file. And second, our file writer is going to have to know what file it should write to. When we're using a file writer, we associate it with a specific file. So we pass into its constructor the name of the file we would like it to write to. Our file writer is capable of creating a file if none exists. So we should just pick a name that ends with .txt so that our operating system knows we're creating a text file. Even though we've called file writer's constructor with valid arguments, NetBeans is still letting us know that we'll get a compiler error in this code. It's telling us there's an unreported exception, an I/O exception, that can be thrown here. Many exceptions in Java are marked as handled exceptions. These are exceptions that a function explicitly states it may throw. File writer is a function that explicitly states that it can throw an I/O exception. So, as far as Java is concerned, it is an error for our code not to explicitly handle this possible exception. To handle this, of course, we're simply going to wrap the portions of our code where we use our file writer with a try catch block. That catches I/O exceptions. If we do catch an I/O exception, it's probably a good time to print out to the error stream. And we'll just give a helpful message. And then our program will be finished terminating, or finished running, and will terminate because it's reached the end of the main method. With that exception caught, our instantiation of file writer is now valid and legal. So let's put it to use. We no longer need our program to print out to our console, so I'll comment out this line of code. And we're going to do the same logical thing with our file writer. File writer doesn't have a print line statement, but it does have the write method. Each time our for each loop executes, we'd like to write this number to our file. Unfortunately, the write method doesn't know how to take a long as input. It can take a string and it can take an integer. So let's use the static string class method value of to acquire the value of our long number to print out to our file. So we should have all the pieces of a successful program here. We have declared and instantiated our file writer, giving it a file name, and then we've looped through our Fibonacci sequence of numbers and told our file writer to write each of these numbers to out.txt. The question is, though, where is out.txt? We haven't given the file writer a full system path, just the name of a file. We know that the file writer is capable of creating this file if it does not exist, but where in our system's directories will this file writer choose to create that file? To answer this question, we need to know where NetBeans is creating the .jar file for our compiled program. To find this out, we can open the console window and build our program. Here, NetBeans will tell us where it's creating all its files. For me, it's a folder writing to files. And if we navigate to that folder, we'll see our project files. One of these files is dist for distributable, and this is where our jar file is compiled to. Jar files are as close as we're going to get to an executable with raw Java code. Because Java code must be interpreted by the Java virtual machine, we can't actually create Java executables. But in most operating systems where Java is installed, we can run a jar file by simply double-clicking it, like a executable could be run. We can also tell the Java virtual machine to boot up and run a jar file using the Java command line -jar command, followed of course by the name of the file we would like it to execute. When I submitted that command, the Java virtual machine interpreted and executed our writing to files.jar program. It looks like it worked because a new file was created in this directory. This is the working directory, and until we move it, it's where our jar file is executing from, or where the command that executed the jar file is executing from. So that's where our file writer chose to create out.txt. Unfortunately, when we open up out.txt, there's nothing for us to see, leading us to believe that our file writing probably didn't work. So what went wrong? Well, there's an important piece to using a file writer that we failed to take into account. When our file writer is created, it opens a file. And whenever we open a file, we should make sure that in the end, we close it. This is pretty easy to do from a code standpoint. We simply call the close method on our file writer. Here's a familiar error message though. Out.close can also report an IO exception. We could put out.close within another try-catch block and handle this IO exception. But if our file cannot be closed, that's a sign that something is very seriously wrong. In this case, it might be appropriate for that exception to keep propagating upwards, and us to pass it on to a more robust piece of code, rather than our fairly contained writing to files program. This will happen by default if we don't handle this exception. But we do need to let Java know that this exception propagating upwards from our current code is a possibility. When we declare our main method, we can also let Java know what exception types might be thrown by this method. Here, we tell Java that under some circumstances, our main method may not execute perfectly and will instead throw an IO exception. Now, anyone who calls the main method of writing to files will need to handle this exception themselves. If we build our Java program and then execute it again, we'll see that out.txt has been properly printed to. Unfortunately, we forgot to put new lines in our output, so there's no distinguishing spacing between the numbers. When we write, let's append to each number \r\n, a new line escape character syntax that's going to be visible to just about every operating system and environment. It's time again to build, run, and take a look at out.txt, which now is starting to look pretty useful. So that was our initial stated goal, to print this Fibonacci sequence out to a file. A few quick things before we're finished here though. Let's take a look at what happens if we run our program again and then take a look at our output text file. The text file looks the same as it does before, which may or may not be expected. It seems like it's kind of a toss-up if FileWriter would clear this file and write brand new text, which is what it appears to have done, or if it would have put the text appended after the existing text in the file. By default, our FileWriter will clear a file before it writes to it anew. But we can toggle this behavior through a parameter in the FileWriter constructor. If we set its append behavior to be true, build our project, run our project, and take a look at out.txt, we'll see twice as much information as was there before. Our text is now appended at the end. Lastly, there's a lot of different writers available to us in Java. FileWriter is just one of them. I decided to show it to you here because it's pretty simple. It takes some text and it prints it to a file. Very often, however, you'll see FileWriter wrapped around by the BufferedWriter class. And the declaration of the BufferedWriter class will look like this, where a BufferedWriter is created and given a FileWriter as its input. The BufferedWriter is pretty cool because what it does is intelligently take all the commands you give it and attempt to write to a file in the most efficient way possible. This program we've just written here is, from our point of view, going to do the same thing as our existing program has been doing. However, in instances where we make many small writes, like this one, BufferedWriter can be significantly faster. Because, where appropriate, it will intelligently collect the right commands we give it and perform them in the proper blocks to maximize efficiency. For this reason, very often you'll see Java code that looks like this instead of the FileWriter being used in isolation. See you next time.